It's Sunday night, and we're here live at CMN Studios here in downtown Chicago.
Hello and good evening. My name is Emma Kurian, here with John Zahar, Raj Shah, and Srav Putnick. Coming to you live from the Central Math Network.
Tonight, we have many stories for you. Isn't that right, Srav?
Yes, sir. Today the topics range from derivative discussions to imperial politics.
And that is only the beginning. Are your cosine graphs looking a little loopy? Hear what math teachers around the nation are saying later tonight.
But first, we have a special airing of the song that's been topping the charts for weeks. Performing live from our studios are the Cosmic Brownies and their single, Newton Started the Fire.
Sounds radical.
Calculus, derivatives, slopes, and power rule, instantaneous rate of change, all that stuff is really cool. Take a function 3x squared, it's not that bad, don't be scared. Exponent comes down to the coefficient, multiply it 2 times 3x. If you have a constant though, derivative is 0. Quotient rule is not that bad, low d high minus high d low. Take the difference over low square, we're glad to know that you have cared.
Newton started a fire, it was always burning, now we still learning. Let it please help the fire. No, he didn't light it, but he stood beside it.
Chain rule is trickier, better than Karun's dancing. F prime G times G prime, there's your answer. Product rule is pretty simple when multiplying functions. F prime G plus G prime F, bring it to conjunction. Then you get to real life motion, positions given by x of t. Drive and you get acceleration given by a of t. If you want to get fancy on your homework, impress Miss Roderick, calculate the jerk.
Newton started a fire, it was always burning, now we still learning. May it please help the fire. No, he didn't light it, but he stood beside it.
Take a break, a hike or jog, it's time to derive two logs. Derivative, natural log, or the slope of L and U. It's not all that much to chew, use the points from Melon's graph. When you do the workout, substitute E for U. You passed the first, now you see it's just 1 over E. Log base A of x, don't forget to double check. When A is positive but not 1, you continue with this one. Derivative is 1 over natural log A times x.
Newton started a fire, it was always burning, now we still learning. Let it please help the fire. No, he didn't light it, but he stood beside it.
Cotangent, tangent, secant, sine, don't forget cosecant, add cosine. Derivatives of these trig functions, keep them in your mind. Negatives and exponents make so much more sense. Derivative of a trig function's based around a different one. Slow it down, you're thinking big, time to move to inverse trig. A function just like our cosine, don't stop now and cut the wine.
Newton started a fire, it was always burning, now we still learning. Let it please help the fire. No, he didn't light it, but he stood beside it.
Derivatives aren't everywhere, not even beauty pageants. One place where they don't exist is a vertical tangent. When you hit an asymptote going to infinity, it's not the worst, you can get a discontinuity. That's when there is a hole, it prevents you from your goal of matching limits left and right, different limits that really bite. Then we get to a different type, a corner or a cusp. It happens when the left and right don't match in derivatives.
Newton started a fire, it was always burning, now we still learning. Let it please help the fire. No, he didn't light it, but he stood beside it. Newton started a fire, it was always burning, now we still learning. Let it please help the fire. No, he didn't light it, but he stood beside it.
Wow, what a math-tastic performance. I think it would be beneficial to our audience if we cleared up a few lyrics. When the Cosmic Brownies reference corners, cusps, vertical tangents, and discontinuities, they're talking about functions which fail to have a derivative at a certain point. For example, a corner is a non-differentiable for the fact that one-sided derivatives differ. A cusp has secant lines that approach both infinity and negative infinity. Vertical tangents have secant slopes that approach infinity or negative infinity from both sides. And finally, discontinuities, which cause one or both of the one-sided derivatives to be non-existent. John, what's your perspective?
Well, Emil, I really like Chris's line f prime g plus g prime f explaining the product rule. You see, you take the first term and multiply it by the second term's derivative and then plus the opposite. It's really that easy to take the derivative.
I really like Karun singing in this video. I think he did a great job in explaining the derivatives of log and natural log of x, and show the audience how to take the derivative of each as well. He hit on some key facts like the derivative of natural log of x, which is 1 over x, and the log base a of x, as long as a is greater than or equal to 1, which is 1 over natural log of a times x.
Personally, I thought Sriram's part about the trig and inverse trig functions was the best. When he stated cotangent, tangent, secant, sine, don't forget cosecant and cosine, I liked how he stated how the derivative of sine is cosine of x, and how the derivative of cosine of x is negative sine of x, and how that repeats like in a process. Next, I'd like to clarify a little bit about the inverse trig functions, because it's a little more confusing. The first thing to remember is that they come from two equations. Sine squared of x plus cosine squared of x is equal to 1, and 1 plus secant squared is equal to tan squared of x. So the derivative of inverse sine is 1 over the square root of 1 minus x squared. The derivative of inverse cosine is negative 1 over the square root of 1 minus x squared. And the inverse of tangent is 1 over 1 plus x squared. I'm Raj, and for Sarav, Emil, and John, remember Chicago.
Take it to the limit.